this computer because I like having those files because I like them not getting deleted at some point. All right. So Irma is due this Friday, I believe. So let's go. So I plan on talking about it for a bit, and then I'll go over administrative stuff. So first off, if you're using Visual Studio Code, you may have noticed that if you get your file, and let's just go ahead and print, running. Okay, and you hit that run button, we get a tkinter error if you run that. You either need to open the folder or you select over here, run without debugging, or over here, and then it will start running without the error, okay, if you're in VS Code. Or alternatively, close this, drop the file in here so that it knows about all the other files, and then you hit the run button, and it should work now, I think. Yes, it should work now. All right, and then I got another question about from another student about like, okay, it flickers but then the background goes away. Let me go ahead and so T is the name of our turtle in this one. So if I do t.done, which is really important if you're using VS Code, this is not something you have to do if you're using idle. And I run this. Okay, t.done. Is it, I think it's turtle dot, or is it turtle.done? Turtle.done, probably. There we go. It should stay up when I do turtle.done. But this background sometimes appears white if you don't have, or flickers away if you don't have any code. Don't worry about that. Once you get your hurricane moving, it should work. Okay. So that's just kind of one thing I wanted to mention about this before we start working in general. So you probably got a whole bunch of email announcements last night because of all the grades that got uploaded. This is due to me importing the Runestone. This is due to me importing Runestone. Let me go ahead and show you what I did here. So give me 1 second. My drive and okay. And what do you mean? Let me show you what I've done. I'm not going to show your grades or anything like this, but what I'm going to show you is that I did this using a Python script, which I call gradecombo.py. And this is one of the things that, so first off, I get two separate CSV files, comma separated value files, meaning it's got your name, comma, your email, comma, and then like grades. It's just basically big Excel spreadsheets that are able to be read in plain text. Okay. And then what do? I have one from Runestone and one from Canvas, but they don't exactly match up greatly because sometimes people make duplicate accounts. Sometimes people's names don't match or the emails don't match. So I can't just simply copy paste one onto the other unless I want to spend hours going through the rows properly, which is, I don't want to do that. So instead, what I've done is I've written a script to let me do that, a Python script to do this. I have two ways of, this code has basically two steps. So first off, I set up over here a Rune hash and a Rune CSV. Let's see. Sorry, Rune emails. So this takes your name and gives it and associates it with your data. So basically this is dictionaries, which is what we're going to be focusing on in the next homework. Dictionaries say, let's take an arbitrary key instead of in a numbered index. Let's take a random key and associate it with a value. In lists, they associate a index with a value. Here we're associating any key we want with a value. So I'm saying, let me associate your name with basically this giant string, which is your grades. Okay. And then what I do is I also associate your I say, given your email, I can also find your name. So I look through Runestone, get all that data. And then what I do is that I open up the file for Canvas and I say, hey, get your name, get your email address, because what happens is that basically your email address has Canvas gives me your TU account name, so TU whatever numbers you are, and then so I just simply add at temple.edu to the end of that to get your email address. And so what I say is hey, is your name one that I saw before? If so, I'd like to put that row, I'd like to take what's there and add what was from Canvas. Sorry, what was on Runestone to the end of that. Otherwise, if I don't see your name, but I do see your email, I'll associate that way. And then over here, if your name or your email didn't work, I try a couple different things, which is I remove your middle name or your initial to see if that matches up. And if that doesn't find it, I just don't, it doesn't copy anything over, and I leave that for it to be done manually. Okay. So this works so this works great for basically speeding up the workflow. But this is what I was able to do with file reading. It took me about half an hour to write this, and it saves me about 3 hours of work every time I run it. So that's how, and so then I take your exported CSV file and upload it to Canvas. And that's why you get all the grade notifications, because those are being imported. If again, refer back to the email if you've got zeros. If you've got a duplicated account or your grades are all missing, please let me know in an email. Also, administratively, I had some issues with the group exams, mainly because I've graded them all, but I didn't get the group names from everybody. So if you don't have a grade for your group exam, just let me know. I've got in one email, plus 2 groups have handed in like a slip to me with all the group names on it. So just get that information to me, and I'll be sure to update it this week, so that, and copy over the score so you know what you have. Yes.
Is the solo exam fully graded?
It should be. If there's issues with the exam, please let me know. I know that some people have sent me an email to regrade it. I just hadn't gotten to that because this was an insanely I did not get a spring break. It was very busy. I've caught up on everything that I need to now, but it got weird. Doesn't help when your kid gets sick during your the kindergartners. They're just germ machines. Okay. So anyway, again, with regard, also I had to handle one of my TAs going on strike, which is now over. So I had to do a bunch of the grading he wasn't doing, but strike's over now. So I guess that point's moot now. So it was, yeah, that's what I mean. I said that I kind of got backlogged. So now with regards to the unsatisfactory ratings that I've handed out like candy, and I did hand them out like candy. Don't feel bad if you got them. I basically went through very late last night and was like, okay, did you score below a 70 on the exam? Unsatisfactory in the solo. And that was just in the solo grade. I didn't even take into account the group grade there. Okay. And then have you not turned in? And then my second clause was, are you missing a ton of Runestone work and have less than like a 90 on the exam? If so, unsatisfactory missing. So there were a couple different clauses I used there. It is simply because it is my quickest way of administering a heads up. You need to make sure you're getting your work into a student as quickly as possible. Now, my goal is that even if you completely bombed this first exam, that shouldn't make a huge the biggest impact in your grade, because what we can always do is I can weight the later exams more. I can also, let's see. Also, I plan on giving like 2 more midterms and the final. So the next exam this is week 8. I would probably like to give an exam on week 10 or so. Just simply to go over those kind of things. Just simply so that I can make sure that like I can give out a few exams and make sure that each individual exam doesn't have the largest impact, a disproportionate impact on your grade. That exam will most likely cover like things since the first exam. So for loops, writing functions, more kind of classic problems that you would get in homework 4 and 5, and or things like what we've done, or the in-class for loop exercises. Maybe touch on a bit of file reading, a bit, with something along the lines of read a file and then basically sum up the data in the file. So something simple. So an example of what I would expect on exam 2 for file reading is, here's a file. It consists of 2 columns. Okay. And I'll just go ahead and write here. Column A is animal type. So what kind of animal it is, and the number of animals we have. Okay. So, and basically it is always, and it is comma separated. So it would be like this. Okay. So it might be goats, 17, giraffe, 4. So maybe the data looks something like this, and I'd be asking how many total animals are there? Given this file, read it. Tell me how many animals there are out there. And it's not a matter of like, and you don't get credit. You have to actually read the file. Don't get credit for like copying and pasting the data in and then manually counting it up. I'm saying like you have to open the file, read it, or have the code that would open the file and read it, if that makes sense. So those are the kinds of, but that's about the level of difficulty, which because if you're wondering how that could be harder, it would be harder by saying, okay, how, I could put on some other things like, like class, and say, this is a mammal, this is a mammal, this is a reptile, this is a reptile, please count only mammals. So that's how those things can accelerate in difficulty, but I plan on just keeping it on the very basic kind of thing. Okay, so I will look at as to when we should do our next exam. Most likely it will be, I feel like next week would be way too early because we just got back, right? So I'm probably around the 31st and the 3rd. Also, religious holidays are quickly approaching. I know Ramadan is, as well as Pesach. If you need accommodations due to that, please let me know. I don't necessarily want you to take any exam or otherwise while you're fasting, because that would be not an accurate assessment, I think. So, all right. So let's go ahead and look back onto Irma for a second to give you some pointers on it. Some of you may be having trouble reading the file at this point. So let's see. So in order to read the file here, let's take a look at this thing where basically it says, do not change the code in this function. We're not going to change any code. Well, actually, I will change the code to show you that it doesn't work. So it may be hard for you to see, but over here, it's got like the other things in the folder over here, the data, the images over here. In fact, let's go ahead and open up this over here. We've got Irma, we've got our images, and image 1 is the Atlantic Basin, the background. And this over here, image 2, hurricane, is the hurricane. Then over here, we have a bunch of CSV files. We don't just have Irma, you could read a bunch of other ones and test your code on those too to see that it works. So here, what this does in Irma setup, it says creates the turtle screen with the map background and coordinate system set to match the longitude and latitude. Returns a tuple containing the turtle and the screen. Do not change the code in this function. So it imports tkinter, which is one of those platforms it uses to draw things on the screen. Turtle uses tkinter. It just kind of hides it from you. But here they're doing a couple things to be able to help read the background image. So here it sets up the size of the window. It creates a window object just to be able to say, hey, here's the title of the screen. So when I wrote the code, it says Hurricane Irma over here rather than what it would say by default. Let's see what it would say by default if I were to change that. By default, it would say Python Turtle Graphics. So here it gives it a relevant name. Kludge to get the map. So this is a hack to get the map shown as the background image. Since Windows.background pics does not allow you to position the image. So here it gets the canvas So here it's basically saying you've got the screen, and then you've got what you want to draw inside of it, which is the canvas, which is, in this case, the, the actual area that a turtle would draw on. And then here, what it's saying is set the world coordinates. Normally you're at 0, 0, and you're just moving by pixels. But here, what world coordinates allow you to do is set like, what are the dimensions of the image using the bottom left corner and the top right corner. So that's saying the bottom right corner of this window. Yes, I know normally we do pick 1-to-1 for pixels, but here the bottom right corner is -90 and 0. And the top right, sorry, bottom left corner is -90 to the right and 0. And then the top left corner, sorry, the upper right is going to be -17.66 and 45. What is that saying? That's saying that this, that over here, that we consider this corner over here to be 0 on the y-axis, and this over here is 45 on the y-axis. In other words, in other words, this bottom edge, that's the equator. That's the equator there. And that's 40, and this is 45 degrees. Is that latitude or longitude? Yes. Is it? I'm not sure. I honestly don't know. Let's look it up on Wikipedia. I really do not know. I don't keep track of these things. I know that my fourth grade teacher is, Miss Krasner is basically hanging her head in shame right now, but okay, latitude is the coordinate given to north-south. So north-south point. So that means that these they go around. So that means that the latitude corresponds to what? X or Y. They correspond to Y. And how do we normally phrase latitude and longitude? We phrase it latitude and longitude, which is YX. That is so make sure when you're moving your turtle to the right position, you're making sure you're setting it to the right X coordinate and right Y coordinate for latitude versus longitude. If this has prevented you from finishing the program, do not feel bad. I like to do these assignments before I hand them to students. That was a 3-hour bug for me. It took me 3 hours to figure out what I was doing wrong, and the fact that it was just that I flipped the X and Y axes. Okay, that was the hardest part of that program for me. So yes, I said if it's fine, if the image appears and disappears, it should stay up while you are doing this. But I mean, if the screen disappears, that's not your code's fault. This is Irma setup's fault. If the background is anything to do with the background, that's that's the Irma.py image. Now, the other thing I want to mention is that it says the map background image is a photo image file is equal to, ignore this part. What you need to know is that it's looking for a file, and then it says images / Atlantic-basin.png. That means if we want to read a file or any file in this, right? Anytime when I've been talking about reading the file before we went on break, I said, hey, make sure the file you want to read is in the same folder, right? Well, these aren't in the same folders. They're in the folder that's in the same folder. So in order to do that, in order to look for something in images, you say the folder name / the file. So here it looks for images.hurricane.gif. So if I want to open up, the data file for Irma, right? So if I say path is equal to, so what is the file? So what should I be opening in this code? What, because I can't do Irma.py, right? Irma.csv, right? I can't open Irma.csv. Open is equal to, path R. right, if I try let's see, does this crash now or later? Okay, if I try opening up irma.csv, it says I can't find it because there is no irma.csv in this folder over here. Where is irma.csv? It's in the data folder, right? So what we do to open it is we say not irma.csv, but what? Data/irma.csv. And now it's going to be fine. And now we can read the file. For a lot of these harder homeworks that are coming up, the hurricane tracker, the Hawaiian pronunciation and the pig, expect to be spending some time in class now because they're actually, you know, interesting problems where we can dedicate some class time to actually working on these, you know, so I can, you know, so if you get stuck, email me about that specific point. I'll be happy to bring it up in the next lecture. Okay. So we've got irma.csv, open path. And so now what you can do is that you can read it however you want to, right? You can open the file and you can store this in a variable, then you can then you can run through the file reader however you want. I suggest going line by line, and then you need to just extract the values. So here with Irma, right? What you need is the latitude and longitude for moving. And then you need to use the wind. Then you need to use, I think, either the wind or the pressure to tell what category of storm it is, to color it appropriately. So first, get your turtle moving. Then second, work on altering the turtle as it moves based on, you know, changing the color and the thickness of the pen as it moves once you've got it moving. Make sense? All right. Any other questions on Irma before I move on to more file reading kind of stuff that we can do, that we can get to practice on? Yes.
I have like saved, but it's like saved with Excel, so I just open it in Excel and we'll get that.
Yeah, if you open this in Excel, you can double clicking on CSV files by default on Windows. If you've got Excel installed, we'll open it in Excel. Here, the way I opened it is I just simply took it and dragged it onto here to make sure that it would appear in this folder. See, I just dragged it like that. You can also right click and open it in whatever text editor you want. Other questions? Again, these other homeworks are harder, but don't get don't get discouraged by them. They're harder than they look. Once you understand the tricks behind them, or you understand what you're trying to do, suddenly they kind of become easy. They become, or rather, not easy precisely, but more like you aren't sure how you didn't see the answer before. And that can make it very easy to be unforgiving to yourself. Don't do that. Please have compassion for yourself. It's very hard to put yourself back into the state of being that you were a couple hours or a couple days ago. Okay. All right. Now, with regards to what I wanted to try to do today, even though I've used 25 minutes, that's perfectly fine. Let's go to our modules. And I think I have a Runestone activity that I've got set up for the day. The plan is that I want to go over this first one, which has nothing to do with dictionaries. And then, oh, did I not edit it? Give me 1 second. I did. I went through and edited it, but I did not save it. Okay. Boom. Link options. Change this to from 22 to 23. Done. I did this already when I was upstairs. 22 to 23. Did that stick? No, it did not. 23, done, save. That's what was missing when I did that. So now you should be able to click on these and it will take you to the appropriate project. So in Runestone, the project is, if we scroll all the way down, it is It is exploring common words and SETI. So today we're going to be learning about ZIPS law, ZIPF. I'm not really sure how to say it. It's really hard. ZIPS law. So you can go get there by scrolling down to project 11 or by clicking on this. So the idea behind this is that language is kind of interesting, right? It's if you've ever learned a foreign language and then start listening to like television shows or communications and that, you start realizing that even though you don't know too much, you can start picking out words here and there. And it's very common when you're able to pick out words. And this is because language frequency distributions of words are not equal. There are words that are more common than other words. Take the word the, for example. The word the occurs a lot of times in various sentences. And I think that's a very interesting fact. And this is kind of, this language analysis is really hot right now. And this is kind of, take things like ChatGPT and trying to figure out how they understand how these things work. So it's got to figure out a language, and it's got to figure out context for the language. Context is also very highly dependent. So in this lab, what we're going to be doing is we are going to answering the following questions as it explores Zipf's law. What are the 10 most commonly used words? How does the frequency of most common words compare to the least? What percentage of usage do the top 10 most common words represent? And then what we'll do is that I'll quickly show you how I can use something called Altair to plot this, even though I'm just going to totally steal it from what I did last semester because I don't have the time to refigure that out. And what you'll see is that if you study signal systems for different samples, you'll see that human communication will follow this law, as does communication for bottlenose dolphins, humpback whales, adult squirrel monkeys. There's some signals you will get, some samples you will get that are more frequent than others. So what we've got here is a small snippet of the word frequency data project, which is the 5,000 most commonly used words. So this is part of why I love Runestone. This file is something you can open on this page. You can literally use the open command on it. And it is a file. It has 5,000 words on it. Okay. And let's see. So for instance, this is gallery. This is word 382 is gallery, noun, and then we have two other things, 8963 and 0.93. So the other ones is just, so let's see, give me 1 second. Aha. So this one is how often they've seen it, how many times they counted that word, and then dispersion. In other words, is this used everywhere or only in specific writing? They mentioned that with regards to the word RE has a frequency of 15,773, but its dispersion is only 0.47, like gallery, meaning that, oh no, gallery had like 93 something, 80s, but RE has only 0.47, meaning that you only see it clustered in certain documents. You only see it in places that seem to use RE a lot already. So if we look at our words, we see the, be, and, of, in, to, have, and to. We see actually to occurring a few times. To as an infinitive, and T as the infinitive, and I as a preposition. So different points of speech for to. So these common words make sense. The is used a whole lot. Be, and is used a lot. So these are very common words we would see. So our first task is to read this file and store the contents into 5 lists. So remember, as you read each line of the file, the line is represented as a string. Your goal is then to split the line into 5 parts and put those parts in an appropriate list. So we can start, and just to start out, let's go ahead and say data is equal to open. And the file was, let's see, what was it called? It was called words 5000 words5000.csv. And we're going to go ahead and open it. Oh, we've already opened it, and now we can read it now. We can iterate through it. For data print line, we can just simply go through and we can see that we have successfully read this file, right? And of course, every line has a new line after it because you print a new line and then there's a new line in the line you read. So that's why it's kind of double spaced there. So we need to split this line into 5 parts and then put them, and then we want to split those parts into 5 lists. So those parts were the rank, the rank, which I feel is unneeded, the word, the preposition, the part of speech, oops, and then the frequency and the dispersion. So let's go ahead and create 5 lists. Rank is equal to word is equal to part for part of speech. And let's see, frequency, so freak, because why use 4 letters? Why use any more when 4 will do? It was enough for early RPGs, darn it. So rank, word, part, frequency, and all right, dispersion. So for each of these, we need to split it up into those split this line up into parts. In other words, we go through, we split the line, and then we add each of these into that. So how do you add something to so in other words, what we need to do is that we've got some line here. Line is a string. Okay, so we have 2 things we need to do. We need to use split, which takes a line into and turns it into a list of strings. Split will turn a string into a list of strings accordingly. And then what we can do is that given the name of a list, to add to a list, all we have to do is append to add it to a list, right? So go ahead and take a few minutes to try to work that out on your own. I'll come back here and show you how to do that after to get to our full answer, and then we'll move on to the next part. So going around, I see a lot of people still kind of shaking off the spring break, week of not practicing. That's perfectly fine. I'll take that into account for the next parts of this exercise. Gesundheit. Mhm. All right. Hmm. All right, so let me go ahead and show you what I'm talking about. So we're iterating through every line in the file that we're opening. If I do line dots, and so what I'm talking about here is doing line dot split. So if I say if I print, so we were printing line earlier, but instead if I print line dot split, assuming again I can spell these things, I swear. These gloves make it impossible. Okay. Okay, and what we get over here when we do that, when we split it, is that we get, well, not much. All right, because I've got to split on the commas because it's a comma separated value file. So if I split on the so split splits up a string by default. It will split on white space. There is no white space here other than the end, separating the items. Instead, we're separating by commas. So if we do this now, we'll see that every line is, so here we've got our first one, which is rank, word, part of speech, frequency, dispersion. 098. 2B and 2BV, and so on and so forth. 12, that's the, and so on and so forth. So what we can do over here is once we split it up, we can take each of these individual parts and append it to the appropriate list. First thing I'm going to do though, is I'm going to do, let's see, can I do this? I forget. Let's see. Can I slice this? I always forget. No, I can't slice a file reader. So instead, what I'm going to do is I'm going to do this instead. Because what I'm going to do is I'm going to get rid of that first line. If you didn't get rid of that first line, that's okay. But I'm going to get rid of that first line because I don't need it. I don't want the legend in there. So let's call it lines is equal to data.read lines. And now if I do for line in the lines, that goes through, same result as we had before, but now I can do a slice. And this says everything but from line one on. I'm going to read it. And so now we don't have the legend in there anymore. So now that I've got this, let's go ahead. I've got a bunch of strings. Let's go ahead and call them strings because why not? I'd call them parts, but I already have a variable called parts, and that would get, a bit confusing. So now I can say, hey, so the rank is the first part. So to append strings 0. And then what we can do here is we have 5 of these. So it would be 1, 2, 3, 4. So we have 4 parts. And we do that. And the order is the rank, the word, the part of speech, the dispersion, the frequency, and the dispersion. And then we can test this by printing out whatever we want. Let's go ahead and print out word, the first 10 words. Okay. Run it. And then we get the first 10 words. That is the, be, and, of, in, to, have, to. So as a bonus, here's a comic. So what we've got here is the word sustainable is a graph showing that the word sustainable is unsustainable. Namely that here's time from 1960 to 2140. And here's the frequency of the word sustainable in US English text as percentage of all words by year. So as we moved on in the 1960s, it was barely a, let's see, 10, 100, 1000, 10,000, 100,000. One is barely a millionth of all used words, a millionth of a percent. And now it's getting closer to about 1 in, sorry, what was that, a million? Sorry, 1,000th of a percent, somewhere between 1,000th and 100%. And so if we extrapolate that data, which is always perfectly accurate, then by 2036, sustainable will be occurring on average once per page. By 2061, it will be average once per sentence. And if we go through this, all by 2109, all words will just be sustainable over and over and over again. So why are we talking about this? Well, because this is a graph of what we call a good example of a graph on the log scale. See, everything has a purpose in this. So what is a log scale? So a log scales XKCD will say that log scales are for quitters, but who don't have enough paper. But the log scale is what you use when basically you can't, when you're trying to show differences between things in graphs, but you can't because they are orders of magnitude different. This is why the most common use of the log scale you will see in life is basically the Richter scale or the decibel scale, one of those two things, depending on what you work with. There's a huge difference between a Richter 6 earthquake and a Richter 7 earthquake. Those are huge orders of magnitude difference in the amount of energy released. It's not just like, a 1/6 of a point more. It is an entire order of magnitude. It is basically saying it's a huge difference is the point. Same with decibels. But this is what we see over here on a log scale. When we get a log scale, we see that each of the data points, each tick on the y-axis, rather than going up by 1, it goes up by a factor of 10. Doesn't go up by 10, it goes up by a factor of 10. So if we were to actually graph it out, it would look kind of more of an exponential or logarithmic kind of curve, depending on how this falls out. So Zipf's law is this law that uses this logarithmic curve that says, hey, that you've got this rank distribution in linguistics that basically the most frequent word will occur approximately twice as often as the second most frequent, 3 times as often as the most frequent. So the most English, the is the most frequent word, 7% of all words used. And the second one in this particular count of numbers Of was 3.5% of all possible words. And then followed by and, very closely. So, and so if we graph this, so basically this shows, okay, each thing goes down by basically half. Oh, sorry, each thing occurs half as often as the other one. And so what we do is we get this kind of distribution as a result. It's just saying that basically that in language, things are not equally distributed. We have words that are common and we have words that are uncommon, and the common words make up the majority of our conversation. For instance, in you know, as we put in, and this is true for all languages. If you take a Japanese class, you will learn that the sentences typically end with mas or des as a polite ending for a sentence. So those are very common words that are much more frequent. I'll go ahead and share this code. And I will share it on Zoom just in case you can't get. I will share it later. But regardless, I'll be using it here. That's kind of the point. So the first thing we want to do to calculate does our data set follow this law is that we need to turn the frequency of each word into a percentage. So what we want to do is calculate the total usage percentage of the top 10 words in the list. Store this variable in top 10, and at the same time calculate the percentage for bottom 10 words of the list and store then the bottom 10. What it's asking for is, okay, we've got our data set and it's showing a frequency count for each word. What it wants to know is, what is that percentage wise? Because that doesn't give us a scale to work off. Okay. 200 and, we've counted the 22 million times. How many times out of how many words? That's what we're trying to ask. So what we need to do that is, well, first, let's go ahead and grab the rest of our code over here. So we've got this. So we've got our code and we've got our numbers. Let's go ahead and make this a bit easier to work with. So I'll turn that rank into an integer. I'll turn that the word doesn't be turned. The frequency should probably be turned into an integer because that's a number. And the dispersion, we can turn that into a float, but I don't think we're going to use that. So at the end of the day, that doesn't really matter. Okay. Test to make sure it doesn't work. Okay, it compiles fine, but now it's testing. Saying the error top 10 is not defined. Okay, fine. So top underscore 10 is equal to 0. Bottom underscore 10 is equal to 0. These are variables that they want us to use to store the answers. And so what we're supposed to see is that basically those first 10 words are going to make up 27% of all language. So how do we do this? Well, the first thing we need to do is figure out how many words were counted overall by far. We can do this in one line, actually, if we think about it. We could, in other languages, we might have to think about doing a running tally as we do this. Basically, as we read this number in frequency, add it to our total number of words. But here, what we've stored, this is this column over here. So we just want to add up all the numbers in this column to figure out how many words there were total, right? So to figure out how many words there were total, we can say num for num underscore words is equal to sum of the word frequency. Print num words. And we run that and it says that we read, I think that's hundreds of, let's see. Yeah, it's hundreds of millions, 329 million words. That's how many words were counted in this. Okay. So now what we do is we now can figure out what the percentage is for all these, right? We can say, okay, we can say print, sorry, for each word W for each I in range 10, because I'm going to do the first 10 words, right? What I can do is I can look at this. I can say, okay, first I'm just going to print it before getting the answer, but I'm going to print out, okay, word, the ith word, so rank 1 over there, 0. It occurred this many times, which is what we're really interested in. And that is equivalent to what percentage of number of words? Okay, and so we run this. And it says, hey, the occurred this many times. Let's go ahead and make this a bit prettier because it's all uneven. So let's go ahead and say separator is equal to the tab. That means that for all these variables separated by commas, rather than putting a space in between each of them, put a tab in between each of them. And that almost worked. Okay, so for that occurred 220 million times, and that made up 6.6% of the language. B occurred 38%, occurred 125, so that's about half the time. It occurred about half of the time as the most frequent word, which is 3.8% of the language. And is pretty close. These are pretty close over there. And then we get another happening to N. So we've got this cluster of words here that occur roughly the same amount of time. And then we get another happening and then another kind of happening over there. So that's, but anyway, we can see that basically these languages are 6, 3, 3, 3. So we can add these up. So give me 1 second. Yes.
Just showing. Thank you so much.
Sorry, it's a bit hard when this tries to eat up like a huge portion of the screen. Yeah, I have to zoom in so that everybody can see it. Otherwise, it's just, and that just makes this part even bigger. So anyway, print this, and now we can say, I'll go ahead and work on this while we're doing this. So top 10 is equal to, I'll go ahead and rather than adding up all these divisions, what I'm going to do is I'm going to do it probably the way they expect me to do it, which gets you slightly different numbers because of the divisions. Frequency I, and then top 10 is equal to top 10. So we add up the number of words that are in the top 10 words and divide it by the number of words, which gives us our first answer. Okay, and then save and run that. Sorry. And then, but that does get us the expected answer. Okay, yeah, apparently it was looking for close enough, so I don't need to do any of this nonsense. I can just simply add in up the percentages. Okay. Look at me trying to outsmart the auto grader there. Okay, so save and run. And there we go. So this is close enough. So our first couple of words made up about 27% of 10 words make up more than a quarter of all the spoken words. And we hear that in the sentence I just said. Okay. So now now over here, we want to take a look at the bottom 10 words. So what we have to do is we have to figure out what are the last 10 words. And I could be, clever and try to figure out the indexes. I can do the same thing over here, which is, and why not? So, but the range has to be a bit different. Or does it? Actually, we're working in Python, so the range can be a lot easier. So instead, what I'm going to do is range 1 to 11 over here. What? And then I'm going to do this. You gotta love this part where basically you can just do the negative. Okay. So I started at 1 here. Why 1? Because -1 of an index, right, is the last thing in a list, right? -2 is the second to last 3. -3. So the last items are -1, -2, -3, -4, -5, all the way up through -10 and including -10. Because we're working from the back. And we start at -1 working from the back. Okay, so that's why I went from 1 to 11, and that's why you have the negatives, because it allows us to go backwards. Okay. Make sense to everybody? Let's see. Time is plenty of time. So I go ahead and run this. And we'll see that the last items over here, okay, occur very infrequently. We have till, apology, middle class, kid. So this is the till is the 5,000th word. So it's not the most uncommon word, but it's fairly uncommon as far as these things are concerned. And then it's 1.510 times 10 to the -5th. Doesn't happen that much. Apology. We all know how hard it is to say you're sorry. So it makes sense that that's not as much of a frequent word as we'd like it to be. Plaintiff, that makes sense why it's not too often. Plaintiff probably, and if we look, plaintiff probably has that ridiculously low dispersion as well, because you're only going to see plaintiff in legal documents. It's not a part of normal text, right? Apology, that's normal, that's distributed everywhere. Oh, plaintiff's is at 0.88. Okay, fairly. So it does occur some places other than legal texts, I guess. I'm not exactly sure how we calculate dispersion, but we do see, let's see. Oh, regardless, we have our answers here. But again, these kind of differences between numbers are very hard for our puny human brains to kind of comprehend. Numbers, we understand abstractly. But here's a fun experiment. See how many items you can visualize in your head before the number of items you have in your head becomes groupings of 2 distinct items. And the way that 5 is can be a 2 and a 3, or 6 can be 2 3s. Can't go that high before you start grouping them. It's just the way your brain works. Brains have all these shortcuts for numbers and stuff. And this number versus this, it's very hard to get a good scale because these are orders of magnitude. But on the text, that doesn't look big. Look, it's only like a couple characters more, right? So again, log scales are for quitters who cannot find paper to make their point properly, showing the fuel density in megajoules per kilogram. So what we're going to do is that we are going to graph this. I'm going to go ahead and I am going to go ahead and change the course for a second. Go into fall, where I did this last semester, and I'm just going to blatantly steal the code from there because I use Altair precisely once a semester, and this is it. And you'll see that basically, despite using it once a semester, I use very similar things that in variable names. Okay. So let's see. I will copy this and Let's see. Okay, good. So let's go ahead and move back over here, and I'll probably be able to figure out the rest. Change course. Like I said, I use this precisely once a year. I normally, if I'm going to be doing graph, I prefer doing graphing in Matplotlib, which is like the premier thing. But this is nice because it works, you know, in the browser. And we know it works in the browser. So let me go over here and paste my code in. And it shouldn't be too hard to figure out what's going on over here. So what we've got over here is that, you know, we've got the same code that was going on. I'll hit share code over here. So for a line in data.read lines, what I did is I just, rather than splitting that a former statement up into two variables, I split it up into one. It's the same deal. I went ahead and I added everything. Let's see. Oh yeah, int 10. What did I do with that 10 for? Put it into base 10? No, probably to put it in log base 10. Let's see, what happens if I don't put in the 10? There. Yeah, I don't need that there. But I do need it over here. So over here, what I was doing is I was saying is that as I was adding things, I put in math.log int of line 3, 10. So let's see. And this tells it that it basically I want log base 10 of this number rather than using the I want log base 10 of this number rather than using the actual frequency count. And what this allows me to do is it allows me to basically say, okay, we have, so how does Altair work? You import Altair, you tell it, here's some of the data I'm going to give it. I'm going to say, I'm going to give it a variable called ranking. That's going to take in the name of the variable called rank, frequency for freq. And you can see that those variables names end up here. I say we're going to make a chart of that data. It's going to be a line chart. And then I'm going to code X and Y over there and then display it. And we can see over here that this is so this is 10 to the 8th power for how often they occur. And this is to the 4th power. Now, what we can do is that we can change this up a bit to kind of show you what happens. And so again, this is a log scale. It shows us the relative frequency of what goes on over here. The relative frequency of all of the occurrences of words. And it doesn't seem to be a huge difference, but again, this is logarithmic. This is basically, words up here occur 100 times more often than the words down here. A bit noisy, but that happens. So what does that look like without the log scale? And that's where that extra 10 came in from. So without the log scale, okay, we see that the data is kind of useless to look at, right? But we do see the difference. We see that basically we go into the 20, here we've got into 20 millions and immediately plummets because we're kind of having every few words, the frequency count is having, and it doesn't take too much, it doesn't take too many havings to get down to a low number. Okay. So anyway, this is what Zipf's law is. I've exported this. So I shared this code. So go ahead and refresh your page, see if this pops up. Okay. Does it? Excellent. So be sure to run that so you can get credit. So for all the code that I've shared today, I'm going to hit share on all of them once again to make sure that it goes through. For each of these, what you want to do in order to get credit for today is that you want to reload the page. You only have to do that once now, and then hit save and run on each of them, and it should give you credit for the code for the code that I've shared you with. All right. Now, and again, you'll want to finish up these questions at the bottom over here, the poll questions. Now, let's see. Oh yeah, it's asking for which ones are more spelled forward rather backwards. Let's see, how much time do we have? So we have about 10 minutes left. So in that last 10 minutes, I think I'm going to use that very briefly to kind of talk about dictionaries, which is the next thing and the thing that I want to talk about in our next lecture. So dictionaries are something you may have, so just to be clear, dictionaries are something that if you're coming from a previous language, are something you may have heard of before, but you've probably heard them from a different name. Associative arrays, maps, hash tables. They all end up meaning the same thing. It's an abstraction of the entire idea of a list, and is basically the most abstract you can get when it comes to data structures, which is given a key, give me a value associated with it. A function, in other words, a mapping. Here's an input, here's an output. For lists, we use brackets. For dictionaries, we use curly braces. Here's a dictionary, I called it D. Now, rather than taking an index, you take in a key, and you don't have to and because we take in any arbitrary key, you don't have to declare what they are beforehand. You can say, hey, I'd like to associate the value, the value 0 with the word 0. And that will create that, and that will create a binding between the key 0 and the word 0. If I ask, hey, what is the word associated with the key 0? Sorry, what is associated with the word 0? It'll tell me 0. If I ask what's associated with the key 1, it will say, you numbskull, there is no association with the word 1 because you didn't tell me that there was 1. Okay. Similarly, if I say 2 is equal to banana, just keeping you on your toes there. Okay. If I ask for what the association with 2 is again, it's going to say banana. And if I ask what the association with what the key, so given the key 1, what do I get? It's going to say, you numbskull, I've already told you this, there's no key 1. The keys are arbitrary. You can have gaps between the keys. They're not like indexes. You can have anything be a key. For instance, I can say, let me go ahead and just shrink this down to put it in the center of the screen. I said, shrink this down so I can put it into the center of the screen. The issue with working multiple monitors, D1. So here I can say D apple is equal to tasty. And now we have 3 keys in here. We have 0, 2, and apple. So the key is what you put in. Sorry, the key is what you say is basically says, this is what I want, and the value is what you get. So if I say D apple, I'll get tasty. But if I say D banana, it's going to say there is no key named banana. Banana is a value. It's on the other side, right? This is like a mapping, right? You can't go from the values to the keys. You can only go from the keys to values. It's a one-way mapping. So we use this for a number of, so this is used for a number of things that are not immediately obvious. The first is just that obvious thing though, which is the key value storage. Given for instance, given a username or an email address, give me all the information associated with that, right? The second thing we can use this for is counting. We can count arbitrary things. Arbitrary things. such as I can keep account, for instance, I can keep counts of words. I can say banana has occurred this many times. And I can just simply say, you know, D banana plus equals 1 to keep a count up of the whatever key I had for banana. Or sorry, increment whatever value I had for the key banana. This is also useful for translating things, so as you will do in a Hawaiian pronunciation. You can say, given a phoneme, such as the letter A, if I see an A, I would like that to be translated to ah. So you can have that kind of association there. And finally, these are also used for categorizing, which is a bit more advanced because that uses multiple data structures where you have a key and that's your category, typically a string or something, but your value isn't a key. So if I say it's something like this, cats are equal to tiger, lion, bobcat, house cat. All right, these are all types of cats. That's a category. And now I have a data structure stored inside my data structure. So if I ask for D for what's associated with cats, it'll give me the list of cats I put in. That's categorization. Most of the time, what we'll be using it for is for counting. But in our assignment for Hawaiian pronunciation, what we use this for will be for that translation. For that homework, I highly recommend that you set up, and we'll get into this, that we set up two dictionaries. One to translate single letter phonemes into their sounds, and two to set single letters into their appropriate phonemes, and two to take a pair of letters and translate that into the appropriate phoneme. Phoneme refers to the sound. So for instance, this is all about Hawaiian pronunciation. So for instance, if you want to know how to say the Hawaiian state fish, which of course is humu 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 nuku nuku apua, and you want to know how to pronounce it, it's actually fairly straightforward in Japanese. Those are not Japanese Hawaiian, which is you just simply take the consonant, translate each vowel into its appropriate sound. In Hawaiian, U always translates to U, so hu mu nuku nuku a, pu a, because each of those has a single translation to a single phoneme. Some pairs of letters in Hawaiian have a specific pronunciation. For instance, A and I together isn't a-e, it's I, which if you listen very closely is I-e, I. So, but being able to translate that, so the homework for Hawaiian pronunciation is, given a Hawaiian word, I want you to give me the appropriate pronunciation for it, which we can do because Hawaiian has a lot of very consistent rules that we can use. And I find it fun, at least it gives me an excuse to say humu humu nuku nuku apua. All right, so that is it for today. I shall torture you no longer. I will be working on more details as for the upcoming exam. It will not be next week, but probably the week after, week 10/11. Week 10/11. So I will give you details on that.
I just want to ask for my exam grade.
Yeah, one question. Let me stop recording.